Hello, Algebra 2. We're going to work on our guided practice for lesson 8.5a. This is where you're going to learn the last conic section for this chapter, where we're going to learn how to write the equation and how to graph a hyperbola. And I'm going to show you what it's going to look like. This is what our hyperbolas are going to look like once we graph them. It's those red branches, either opening left or right, or up or down. So that's where we're going to figure out how we get those graphs created based on the equation we're given. First step, we're going to write down our key concept. We're going to write down the standard equation of hyperbola centered at the origin equations, and there's two ways the equation can be written. Here's the first way, x squared over a squared minus y squared over b squared equals 1. And the other way is y squared over a squared minus x squared over b squared equals 1. So notice it looks a lot like the equation of an ellipse, but we're subtracting this time instead of adding. And also notice that we always have the a squared first and the b squared second. So that'll be important as we start to kind of unpack the meaning of what is coded in these equations. We're going to have what's called a transverse axis. It will be horizontal or vertical. We're going to use that while we are graphing our equations, and then we'll have some vertices, and we'll see how that works in our hyperbolas. The focus is always on the transverse axis, and our transverse axis will either be horizontal or vertical. We have a relationship between the focus, which will be designated with the letter C. The relationship between that focus C and the A and the B values will be the Pythagorean theorem this time. And so we're going to see why in just a minute. But just unlike an ellipse where we have c squared equals a squared minus b squared, for a hyperbola, the relationship between a, b, and c will always be c squared equals a squared plus b squared, exactly what you remember the Pythagorean theorem is. All right, so there's our picture of what you see in your textbook on page 518. And if you want to copy this down, you can, but notice it's in a thinking bubble, so it's not required. That's just a good reference point to have as we are starting to understand the meaning of these equations. Here's why c squared equals a squared plus b squared in a hyperbola. So I've drawn a little diagram here with the two branches of my hyperbola, and I've gone ahead and drawn in my a and my b. These will be numbers that are very specific in each equation of our hyperbola, and then here's our focus point. Our focus point will be inside of our branches, similar to the way focus points are inside of our parabolas. Well, we can notice that we can actually write the equation of this circle here. So from here to here, that's the length of c, and it's the radius. And so here I've also drawn in the radius, and the reason I've drawn it here is because I can know that the point AB must be a point on this circle. So I can immediately say, well, I know a squared plus b squared. This is b, this is b. So a squared plus b squared is equal to r squared. So that's what I've done here. But r squared and c squared are exactly the same thing, so I can replace my r squared with my c squared, and there's my Pythagorean theorem relationship. A squared plus b squared equals c squared, which will always be true in a hyperbola. Let's do some practice problems. We'll do 3 guided practice problems to get you into pulling the information out of the equation of a hyperbola so that we can graph it. So our first job, we're graphing the equation x squared over 16 minus y squared over 49 equals 1. And we're going to make sure that we show the vertices, the focus, and the asymptotes that will allow us to know where those branches are for our hyperbola. The first thing we're going to notice is that we have a horizontal transverse axis because x squared comes first. Whatever comes first here, that's going to determine whether or not you have a horizontal or a vertical transverse axis. And x reminds us of the horizontal, so whenever we have that x squared comes first, we will have a horizontal transverse axis. That means that the branches of your hyperbola will open left or right. Whenever that x squared comes first, transverse axis is horizontal, and your branches will open left or right. Now, just like an ellipse, we're going to pull off our a squared and our b squared, and in a hyperbola, remember the number under the first fraction will always be your a squared, the number underneath the second fraction will always be your b squared. So here I am pulling them off, and then solving for a is 4, b is 7, and then I'm going to figure out my c by plugging into the Pythagorean theorem here. So c squared is 16 plus 49 in this case, c squared is 65. C then would be approximately 8.1. That is my focus point. Now, how do I know how to write my vertices? Well, they'll either be 4, 0 or 0, 4. The way I know which way to write it is based on this horizontal transverse axis. So I will put the non-zero number in the x-coordinate position because everything's happening on this horizontal transverse axis because x squared comes first. My focus points will be on the transverse axis, so my focus and my vertices will always align on the same axis. And then these are my b-values. And notice I'm not calling them a covertex because they're not in a hyperbola. They're simply going to allow us to create this lovely rectangle that's imaginary that we can draw in and then draw our diagonal lines through the corners of the rectangle formed by our vertices and our b-values. And so notice the b-values here have the 0 in the opposite coordinate of our vertices. So we're going to draw that rectangle, draw in those diagonals, which are our asymptotes, and then we're going to be able to open our branches of our hyperbola on the vertex, approaching those asymptotes, but never actually reaching those asymptotes. Next problem, guided practice 2, we're graphing the equation of hyperbola again, including its vertices, focus, and asymptotes. Here's our equation, x squared over 36 minus x squared, and I put over 1 in a little thinking bubble to make sure I understand there is a 1 underneath that x squared, equal to 1. Okay, now I'm going to pull off my a squared and b squared. Again, for hyperbola, a squared will always be under the first fraction, b squared will always be under the second fraction, and we get a squared is 36, b squared is 1, a is 6 then, b is 1. We'll work out our c squared so that we can get down to our c by using the Pythagorean theorem. So c squared is 36 plus 1, that's these numbers. C squared is 37, and c then will be the square root of 37, approximately 6.1. Now this time, we have a vertical transverse axis because the y squared term comes first. So whichever fraction is first, that's going to determine where your transverse axis is, and that's going to tell you how the branches of your hyperbola open. In this case, they'll open up and down since we have a vertical transverse axis. All right, so our vertices then will be 0, 6, not 6, 0, again, because we have a vertical transverse axis that tells us that the non-zero number will go in the y-coordinate position. So we have 0, 6, 0, negative 6, and then these are our b-values so that we can create the rectangle and draw the diagonals through the corners of the rectangles to create our asymptotes. Okay, so once we've done that, we can open up our branches of our hyperbola up and down. We'll put in our focus point that will always, of course, be inside the branches of our hyperbola, and we're done. All right, next problem, guided practice 3. This time we're given an equation graph that doesn't look like the equation of hyperbola because it's not in standard form yet. So what we're first going to do, we're going to rewrite that equation in standard form for a hyperbola. Dividing all 3 of these terms by 36 will give us y squared over 9 minus x squared over 4 equals 1, and now we recognize this as the equation of a hyperbola. Pull off your a squared and your b squared from underneath your fractions. And we have a squared is 9, so a is 3, b squared is 4, so b is 2. Then go ahead and plug this all into the Pythagorean theorem relationship, and we're going to get our c value once we plug that all in and work it out to be about 3.6. This is like our last problem in that we do have a vertical transverse axis because the y squared comes first. And so we know that our vertices will have 0 in the x-coordinates. Because the y comes first, then we will have y-coordinates that are non-zero numbers. So we're going to take those a numbers, we're going to write them in for our vertices, 0, 3, 0, negative 3. Here's our focus points. Those are our c values. They'll be on the same axis as our focus points always. And then we'll use our b values here so we can create a rectangle. So we can draw our diagonals through the corners of that rectangle so we can get our asymptotes clearly drawn on our graph. And then we open the branches of the hyperbola up and down, starting at the vertex and approaching those asymptotes, but never actually touching them or crossing over them. And that does complete all of our work for guided practice 1, 2, and 3. All of the problems you're working in this lesson will be similar to this, so use these new techniques that are both similar and not similar to the equations of ellipses. Refer back as needed to what we did in our guided practice problems as your template, and we'll see you next time.